Hi everyone, this lesson is about how we're going to use technology, specifically our Casio CG50 calculators, in order to solve some of these binomial probability questions. Now, this of course is our formula that we've learnt previously for the probability of an outcome in a certain experiment. Remember that P is the probability of success, Q is the probability of failure, N is the number of trials in the experiment, and X is the number of successful outcomes. So when we have an example like this one, let's see how we go. We have 8 trials, so let's make a note straight away in our working that N equals 8. The chance of success is 0.6. Now straight away we could put down that Q, the chance of failure, is 0.4. Remember, P plus Q must equal 1. X is a random variable that represents the number of successes, just as it needs to be defined. Calculate the probability that X is at least 5. So X, if it is at least 5, it means 5 or greater. So X is greater than or equal to 5. Now this is where the calculator is going to save us a lot of work, because technically, of course, this means we need to calculate the chances that X equals 5, or the chances that X equals 6, or the chances that X equals 7, all the way up to, now there's not terribly many in this case, but you can imagine in some other examples where there's a lot more trials, there's going to be a large number of very tedious calculations here. Now, how do I use my technology? Well, I suppose I should show a little bit of working to show my understanding. I should say that this would be 8C5, and we would have 0.6 to the power 5, 0.4 to the power 3, plus ... and I'll write the last one. We would have 8C8, 0.6 to the power of 8, 0.4 to the power of 0. Now this is where my calculator is going to save me so much time, and it's going to be a much more accurate result because I won't have I'll have a smaller chance of making typos. Now I'm going to use the stats app here, so let's run that. To start off with, well, that's fine, we have nothing in there, so we'll go to distributions, F5, binomial distributions. Now previously we would have used binomial probability distribution, but it would only give us an individual result for these things. This time what we want to do is a cumulative distribution. Now this one's been set up to use lists, but I'll change that to the data will be variable. Now I just get to enter. What is the lower number of successes? That's 5. What is the upper value of successes? That's 8. So lower and upper here refer to the smallest and largest values of X that we're dealing with. The number of trials in this experiment was 8, so I'll have to change that. And the chance of success on each trial was 0.6. Now I don't really want to output the results to a list, so I will select, when I say none, it just gives it an output then as a variable. So here we go, calculate. And that's given me the answer directly. That is literally calculated all 4 of those and added them for me. So the answer to this one is 0.594. Let's write that down. 0.594. Now that's it. It's the technology is wonderful. In the past, of course, with a less powerful calculator, we would have had to do each of those calculations independently and then add them all up and then get the result, much more likely to make a typing error. Now the rest of these are going to be done in the same sort of a way. X is at most 4, so that would mean if it is at most, it means it could be 0, 1, 2, 3 or 4. X is less than 3, so 3 would not be included, it would be 0, 1 or 2. Now I might skip part B and part C, I'll let you try them, but part D, X is greater than 1. Well, if it's greater than 1, it's got to be 2 onwards, so the only acceptable answers would be 0 and 1. It's not really that much different. I'll let you do the rest of those for yourselves in the same manner. Now here is just as another example, which I thought we could look at. This one, we've got a binomial experiment has 40 trials. So whereas last time perhaps we might have calculated them individually, with 40 trials there's a good chance that we'll never do these individually. The probability of success is at 0.64, that's P, 0.64. Now I should note that Q then would be 0.36. The random variable X is the number of successes. It even says here to use the technology to find the chance that X is between 7 and 26. So we want the probability that 7 is less or equal to X is less or equal to, so 7 is between 7 and 26. I'm going to take that to mean inclusive, that 7 and 26 are included, so I have less than equals there. Now, as I've noted before, that means we could have probability that X equals 7 plus X equals 8, X equals 9, all the way up to the probability that X equals 26. Just to show our understanding, we'll write the formula for each of those at the end of the list, but we certainly wouldn't write all of them. We would have here 40 C7, P is 0.64 to the 7th power, Q is 0.36. Now 40 takes 7, that would be to the 33rd power, plus all the other outcomes, and finally we would have 40 C26, 0.64 to the power of 26, 0.36. Now what's 40 take 26? That's going to be to the power of 14. And once again, we certainly won't be writing all these out. We'll be going straight back to our calculator here. Let's just hit exit to get from that answer back to where we were. And we'll just change our parameters here. So our lower limit this time is 7. Our upper limit is 26. There it is, 26. Our number of trials is 40. And the chance of success on any individual trial is 0.64. Note that we don't have to enter Q. The calculator will automatically figure out Q by subtracting 1. So it knows what to do. And let's calculate. And there's my answer, 0.611 if I round off to 3 decimal points. So that is 0.611. And that's it. That's how we use our graphic calculators to calculate these things. Now, you might have been wondering why these things also had available a list options instead of variables. So there we go, variables. Now, before I can make use of that accurately, I really need to have a few things in my list. And about the only time I ever use this is if I want to do a cumulative distribution. So I'm going to enter, and it's going to seem a little odd to start with. Let's enter 0, 0, 0 in list 1, and now we'll go 0, 1, 2, 3, 4. So I'm going to imagine here I have an experiment with 4 trials. And the first list is 0, and then each of the entries is 0, then 1, then 0, then 2, then 0, then 3, and so on. So let's now pop into our distributions, binomials. To start off with, I'll do the normal old binomial probability distribution. My data is stored in a list, yes. It's not in list 1. I want that to refer to list 2. If you remember, that's the one that went 0, 1, 2, 3, 4. Now, we don't have 40 trials. We have 4 trials, and let's make it nice and straightforward. Let's have a chance of success 0.5. And when we store this output, let's put it into list 3. So list 3, that's good. Let's calculate that now. There they are, symmetrical as you would expect. And we'll just jump back out of there, and there you are. So if we had 0 successes, that's the chance. 1 success out of 4 trials, 0.25 chance, and so on. There's our outcomes. But those are individual outcomes for individual events, x equals 2 or x and so on. What if I wanted cumulative? Well, I can use the cumulative distribution here. Now this time I can use lists. The lower list, I'm going to say that's stored in list number 1. Remember that was the one that had all the zeros in it? The upper list is going to be stored in list number 2. 4 trials, probability of success 0.5, and this time I'll output into list 4. Now let's see what happens when we execute that one. There they are, and let's just pop back and compare. So what this is really doing in the first instance, so the output came into this list here. So what it's doing is it's saying, if I had from 0 to 0, in other words, just the outcome of 0, it's 0.0625, same as the previous. But the next entry is more interesting. If I had the cumulative total here is from 0 to 1 outcome. So it's effectively added those two numbers and given me the combined result of 0.3125, and that's the chance of 0 or 1 success. This one, likewise, is from 0 to 2. So it's 0 or 1 or 2 outcomes, cumulative total of 0.68, 0 to 3 outcomes, and finally, of course, from 0 to 4 outcomes, well, there's only 4 trials, it has to be 1 at the total of that list. So that's a way of generating with your calculator a list of cumulative probabilities, and you just need to set the list up to be all zeros in the first one, and then the second one to be 0 up to the number of trials. You didn't even need to really calculate list 3 like I did. You could have jumped straight to list 4 to get the cumulative probabilities from 0 up to the outcome required. All right, well that's it for this video. Hope you've enjoyed that, and don't forget to practice these sorts of questions for yourself. See you next time.